All right, probabilities. So the first term here that comes up is the sample space. Now, sample space is the group of outcomes that's possible. That's kind of hard to define it in terms of words, but in terms of a question itself, if you roll two different dice, right? A dice has six sides. This is called the sample space of your two dice roll. It's basically all the probabilities or every single possible outcome listed in a table format. That's the sample space. Doesn't necessarily have to be in a table format, but as long as every single outcome is listed, that would be the sample space. What
Okay.
about for this one? Find a sample space for drawing one card. So if you're drawing one card, right? There's 52 cards in a deck. What do you think the
Mhm.
sample space is? What are the outcomes? So you can get one, two, three, four, five, all the way to ace, or ace to king of diamonds, of hearts, of spades, of clubs, right?
Mm.
There are 52 cards, 13 cards in each suite. So that would be the sample space. It's basically the collection of every single possible outcome. Okay?
Okay. Okay.
They're not going to quiz you on what is a sample space. They will quiz you on something like this. Use a tree diagram to find the sample space for the gender of three children in a family. All right, let's do this. So now we're talking about something called a tree diagram.
Mm.
So this helps you see the sample space, which I'm going to call outcomes from here on out. So there's a family, there's a couple. They want to have three kids.
Mm.
So for the first kid, what are the two possible outcomes when it comes to their genders? So the kid can either be what?
A boy or a girl?
Can either be a boy or a girl. What
Mm.
is the probability that the child is a boy? It's a 50-50 right now, right?
Yeah, 50-50.
50-50. So we're going to give it 1 over 2. 1 over 2 means a half, which is 50%. So that's for
Okay.
the first kid. What about for the second kid? What are the outcomes for the second kid? Does it change? You think?
No, it's still
No,
the
it's
same thing.
still the same. It's gonna be boy, girl, and then boy, girl, depending on what was the previous outcome. And then
Mm.
for the third, it's the exact same thing, right?
Yes.
So you from that B, you get BG. From this G, you'll get BG. From this B, you'll get BG. And then from the last G, you'll also get BG. So this comes from here, this comes from here, and this one will come from here. BG. Now let's write down our
What
sample
do you
space.
mean? What do you mean by BG?
Boy, girl.
Oh, okay.
Now we're going to write down our sample space. So this is a tree diagram. You always start here. Always start here.
Mm.
And I'm going to follow this, all right? The first thing you can do is you can go up, up, up. You see that?
Okay.
You have a boy first, and then you have a boy again, and then you have a boy for the third time. So that's BBB. That's your first sample space. BBB.
Mm. Okay.
What's your second samples? So go up, go up. We already went up, right? So no longer we need to go all the way to the top, and we come down. See that?
Yeah.
Up, up, down. So that's going to be BBG. BBG. What about the third one?
B.
Third one's going to be, well, you go up. The first
Yeah.
one was this, so we've used that one. Second
Okay.
one was this, so we've used that one. That means we've used up this B.
Okay.
So this third outcome is not going to have a second B on it. You're still going to go up here, okay? Because we've already used both of these right here. You're going to come down here. So for the
Oh,
third outcome, it'll be BGB. See if that made sense. BGB. This is
yeah.
going to be the third outcome.
So
What
the
about
first one, we will keep using the first one.
until we finish the first one, until we finish this G at the end,
Mm-hmm. Okay.
we keep using this B. And once that's done, the first letter is going to be G.
Okay.
Hmm.
Come
Okay,
and
just
take your charger. It's not even working.
so just to recap, the first option was top, 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 right? BBB.
Yeah.
And then we went BBG. That was our second option. Our
Yeah.
third option was BGB. And our fourth option is going to be BGG. See that?
Yeah.
BGG. What about our fifth?
It's going to be
Yeah?
GGB.
No, it'll be GBB.
GBB. Okay.
What about the fifth?
It's going to be GGB.
It'll be GBG. GBG. This was the previous one, GBB.
Okay.
So GBG. Now, again, we've used up both of these, right? So that means we've used up this B as well. So now we're not going to use this B. What's the next outcome? There's two more. It'll be down, down, up,
Okay,
G,
GGB.
and then what's the last one?
Uh, the last one is going to be GGG. GGG.
There you go. So that's the eight possible outcomes. So if you want to have three kids, right?
Mm,
That's your sample space. Okay.
okay.
So that's how you would build a tree diagram. It's a very powerful tool. That's what they did here as well. And because there's only two genders, every single probability here is gonna be like 50%. So from here having a boy, this here is gonna be 1 over 2, 1 over 2. Every single probability here is 1 over 2 because it's all independent. It doesn't matter if you had a boy or the girl for your first kid or the second kid, the third kid's gender is independent of that. That's why every single probability is going to be the same in that question. Now let's talk about classic probability. There's a formula for this one. This is the one that the book uses.
Yes. Is that what you use?
No, but I can use this as well. But here's the one that I use. It's just different letters, but the concept is the same. The
Okay.
probability of any event A happening, okay? Let's say there's an event A, they call it E, same thing. That is the number of A divided by the total. So let's say there's a science class. In this class, there are 30 boys and 100 total students. What's the probability that you pick a person, okay, and that person ends up becoming a boy? We're going to use this formula right here.
Okay.
So the probability of being a boy, how many boys are there? 30?
Boys.
And what's the total number of students? 100. So the
Um,
probability of plucking a boy is,
100 or 110?
so it'll be 30 over 100.
100. Okay, let me put on the lights. Okay.
So this formula, right, this one, the probability of E is the number of E divided by NS. NS just means the total outcome.
Okay.
This is going to be the bread and butter of statistics. This is the fundamental formula in statistics. It's very simple when you think about it. It's just the number, whatever you're thinking about, the probability for that is the number divided by the total. So let's see if using that formula we can answer some of these questions. Drawing cards. Find the probability of getting a red face card, Jack, Queen, or King, when randomly drawing from an ordinary deck. So here the question's asking us, what's the probability of a face card? And again, this was the formula. Probability of E was N of E divided by N of S, which just means the number divided by the total. So this is the
Okay.
formula we're going to be using.
Okay.
How many red face cards are there in the deck? It says right here.
3.
Three. How many cards in a deck? 52. So the answer for this is going to be 3 over 52. That's it. And you can plug that in a calculator if you want it in decimals.
Okay.
Did this make sense?
Yeah. But where did you, I didn't see the question. Where did you see 52 from?
52 is just common knowledge. In a deck of cards, it doesn't say that, but no, and there's 52 cards in a deck.
Oh, okay. 0.05.
That doesn't 0.05 sounds right. Actually, I messed this one up because they said a red card. There's actually six. You can have yeah, these are cards. So you can either have diamonds or you can have hearts,
Mm-hmm.
and then there's a jack, queen, king of both of these. And all of these are red. So there's actually six red face cards, not three. So this should have been 6 over 52.
Okay.
So the answer will be whatever you got last time. If you multiply that by 2 would be the final answer. Or you can leave it in a fractional form. I don't know what your teacher prefers. I would just leave it in this form as a fraction. Now this next question is difficult. It says if a family has 3 children, find the probability that exactly 2 of the 3 children are girls. So for this, we're going to go back to the tree diagram, that question that we did, but I'm going to take theirs. It's the same thing that we built. So this question's asking us, what is the probability that exactly 2 of them are girls? So we're looking for the probability of GG. We want 2 girls, 1 boy, right?
Mm.
So again, the formula is the same. Just remember, PA is a number divided by the total. What's the total? How many outcomes do we have here? 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 outcomes. So that your total is going to be 8. That's your sample space, the number of outcomes in your sample space. Now this is the tricky part. How many outcomes has exactly 2 girls? Let's look at the first one. BBB, right?
BBB.
Does
Yeah.
that have 2 girls? Nope.
No, three girls.
3 boys, 3 boys.
No,
That
three
has,
boys.
so that one's out. What about BBG?
No,
Nope. BGB?
no,
Nope. BGG?
no.
Yes, this one has exactly 2 girls, right?
Okay,
One
yeah, two
boy.
girls.
So this is one of them.
Yeah, okay.
GBB is out. GBG is in.
Okay,
So far we have 1 and 2.
okay.
GGB, what about this one?
Yeah, that's
GGB,
two
yeah.
girls.
So that's gonna be our number 3. What about the
Mm.
last one?
No,
No,
it has
because that's
three.
all 3 girls. So there's only 3 outcomes
Mm.
with 2 girls, so the answer is gonna be 3 over 8.
Oh, two of the three children are girls. Okay.
Because there's only 3 outcomes here where there's exactly 2 girls, right?
I'm going to plug it in. Right?
Sure.
Should I?
Yeah, you can do it if you like.
Okay.
Should give you 0.3.
Yeah.
Actually, yeah, 3, what, 8? 0.38 something. 385 maybe.
Yes. So, please, there's something I want to do.
Yeah,
I want to change laptop. This one, the battery is dead, and I can't find the battery, the charger.
okay.
Just so I'm
I can hear you.
you can hear me. Okay, let
Yeah,
me increase the volume. Yeah, it's better now. Let's go ahead.
so this was the question, right? What if we change this up a little bit, okay? I need your help with this. Why don't you look at the outcomes and you tell me what's the probability of getting 2 boys? Exactly 2 boys.
Don't do this.
It's still gonna be over 8 because there's 8 outcomes. But what over 8?
I can't. Sorry. Just give me a minute. I'm trying to expand this.
Okay, wait, I'll make it bigger for you, as big as I can.
I don't even think it's you. I think it's Chooks. Please come. It's fine.
So we're trying to find how many outcomes are there that has exactly two boys. Okay, we're gonna start here. Is this in or out?
Come on, make this thing bigger. I don't know.
This one.
Yeah. Oh, go ahead.
So we're looking for exactly two boys. So let's look at the first outcome. BBB, is that in or out when we're looking for exactly two boys?
No,
No,
it's
that's out.
out.
What about BBG?
It's out.
It's in exactly two boys,
Oh,
right?
two boys.
One,
Yes.
two. So this
Yes.
one's in. So that's our first. BGB,
Yes. It's in.
it's in. BGG,
No, it's out.
GBB,
It's in.
it's in. So that's three. This one's out. This one's out. This one's out. So the answer is still 3/8.
Over it. Okay.
Let me make this more complicated for you. So now we're talking about exactly, right? Exactly. But what if we say at least? So we want minimum two boys. Now we're not concerned with only two boys. We need a minimum of two boys.
Mhm.
So that's the need a minimum. Okay. More is fine, but less is not fine. So now let's see if that is the first outcome in or no in this case.
So at least two boys.
At least two boys.
So it means the first outcome is in.
Yes. So this is in. What about the second one?
Is also in.
It's also in. Third one.
Is also in.
Fourth one.
Is not in.
Five
Is in.
is in. I think that's it. This one's out. This one's out. This one's out. So the answer here, minimum two boys, right,
Hmm.
is going to be 4/8,
4/8.
which is 50%. Final answer. So that's what they can ask you sometimes.
Okay.
Just know that when it says exactly, okay, these are just some stat terms.
Mm,
Exactly means equals to.
okay.
At least means greater than, equal to. At most means less than, equals to. And then it can say greater than, more than, all of these words, larger than. These mean strictly greater than. The number itself is not included. And then you can have like fewer than, less than, smaller than. These ones are strictly less than. It doesn't have the inclusive sign. Okay?
Yes.
And then what else? Or. Or in statistics means plus. If you see or, just know that you have to add some things. You may have to add some things. And in statistics is a little bit more complicated. Or and they mean very different things. Or means a plus, and is a little bit more complicated. Um, and is the probability, okay, let me just write this down. And is the probability that two events, these events are different, have the same outcome. Now that sounds a mouthful. Let me just give you an example. Let's say we have the marital status of people. So let's say they're married, unmarried, divorced. And let's say we have gender. So we can say boy, girl. Let's say unmarried boys, there's three. Unmarried girls, there's four. I'm just going to fill this with random numbers. Again, this is married, unmarried, divorced, boy, girl. What if I asked you, okay, what's the total here? Let me just give you the total and we can do like a proper question. I'm just going to add them up. 3 plus 4 plus 5 plus 6 plus 7 plus 8. So the total is 33.
Mm.
That's your sample space. Your total is 33. The total boys, how many boys do we have here? There's 15, and girls, there's 18. Total married, we have something like this. So let's say this is the table that they gave us. This is called a contingency table, if you've heard about that. I can use this to explain or and a little bit better. What is the probability? Okay, use this formula again. PE is NE divided by NS. This is the one that book uses. It's just the number of whatever event you're talking about divided by the total. What's the probability you pick a boy here? What over what?
It's going to be 1 over 33.
Not 1 over 33. How many boys are there?
It's going to be, boys, 15.
15 over 33, right?
15 over 33.
What's the probability of plucking out a girl?
18
18 over 33. These are
over
easy, right?
33.
These are easy. What's the probability of plucking out someone that's married?
7.
7 over 30. Same concept.
7. Okay.
So these are, you just look at it and you're good to go, okay? But
Okay.
things get a little bit difficult when you combine two events. What's the probability of plucking out something, plucking out a boy and, okay, that's a terrible handwriting, but that means and. Boy and married.
Mm.
It's going to be
Um,
something over 33. Now the
yeah, it's
question
going to
is
be
what?
3 plus. Is it going to be 7 plus um 7 plus I don't, 3 plus I don't know. Married is okay. This one is
So
married.
you're looking at boys who are
Mhm.
also married. Both of those conditions have to be satisfied. The condition of boys has to be satisfied. So we're going this way. And the condition of marriage has to be satisfied. So we're going this way. And the answer and the and component is going to be wherever they intersect.
Okay, 3.
3. So the answer here is going to be 3 over 33. Let's try another one. Probability girl and divorced.
It's going to be 8
Yes.
over 33.
There we go. So that's and, okay?
Mm.
And is where two events, they have the same outcome. You need to find where they intersect.
Mm.
I'm sure the book has some questions on this coming up later. Let's keep going here. For now, just understand that formula. Probability of E is equals to NE over NS. The number of whatever event you're talking about, like divided by the total. This is going to be the same formula that we use throughout this course, throughout any intro stats course.
Okay.
A card is drawn from a deck. Find the probability. In a deck, there are 52 total cards, so your denominator is going to be 52. Part A, a king. How many kings are there in a deck of card? There's one for every suit. There are four, okay?
Mm.
You have diamonds, hearts, um, don't worry about the handwriting. You have spades,
Mhm.
drawing, sorry, can't draw, and then you have clubs, which kind of looks like a tree. So these are the four suits, and then every suit has all cards from ace to king. So you have king of diamonds, hearts, spades, clubs. So how many kings are there in a deck?
There are 4.
Four. Total is 52. So there you go. That's the
15.
answer to A.
Okay.
B.
But in this,
Yep.
this question, you brought this question out from the textbook, right?
Yep.
So with this question, did they put that 52, or is just a general assumption I have to work with
You
under it?
have to know that in a deck there are 52 cards.
Okay.
You have to know when you roll a dice, there are six outcomes. When you toss a coin, there are two outcomes.
Okay.
It's like, if you're given a physics question, they won't tell you there are 24 hours in a day. It's kind of like that. It's expected prerequisite
It's
knowledge is what,
expected for you
yeah,
to
yeah,
know.
yeah, yeah.
Okay.
So in a deck of cards, just know there are 52 cards, and every single suit, diamond, hearts, there's 13 of each. So there's 13 hearts, 13 diamonds, 13 clubs, and 13 spades. And altogether, there will be 52. Okay?
Okay.
That's part A. Part B, four of spades. How many four of spades do you think is there in a deck?
Actually, I have no idea.
So spades, there are 13 spade cards, okay?
Okay.
Ace, two, three, four, five, six, all the way to the king of spades.
Okay.
Maybe this will make it better. Deck of cards. Um, I'm trying to see if I can visualize this. Um, can't really find an app or something. But four of spades, there's only one. There are 13 spade cards. Four of spades, there's only one. How many two of diamonds are there in a deck?
Diamond.
Just one, right? Two of
Okay.
diamonds, just one. What about the king of hearts? How many king of hearts in a deck?
Single.
Just one. Okay,
Just
just one.
okay.
If they specify the suit and the letter, the number, there's only going to be one. Okay?
Okay.
What if they didn't specify the suit? How many twos are there in a deck? There's going to be one from all four suits. So in a deck, there are four
I
twos.
need to go and study that first after the class, so I will be familiar with it since it's expected that I know it.
Yeah. Yeah. So four of spades, there's only one, and in a deck of cards, there are 52 cards. So that's the answer to B. Part
Okay.
C, a face card. So each suit, okay, each suit, see, there are four suits.
Mm-hmm.
Each suit has three face cards. Jack, Queen, and King. Each suit. There's three in diamonds, three in hearts, everything. So in total, how many face cards are there in a deck?
12.
12. So it'll be 12 over 52.
Okay.
Part D, a red card. So these two suits, diamonds and hearts, these are red.
Mm.
The other two, clubs and spades, are black. There's 13 of each, okay? Know that there's 13 of each. So how many red cards are there in a deck? There's 13 hearts, 13 diamonds. So you add them up, 26.
46
Over what?
over 52.
Over 52. Okay, party a club. I think this one you got it. How many clubs are there in a deck? Right here, this is a club.
Okay. 13
13 clubs in a deck. So it'll be 13 over 52. And
over
here, there we go.
52. Okay.
That's the answer to that.
Mm. It looks simple, but it's not.
You just have to know the, yeah, you just have to be familiar with a deck of cards. It is simple because it's just one step, right? Look at these. Every answer here is just one step, and all the denominators is always NS, which is always going to be
The
52
total.
when you
Okay.
think about a deck of cards. So let's do something that's going to be a little bit more familiar to you. Okay? Let's say we roll a dice. We're just rolling one dice. What's our sample space? If you roll a dice, what are the possible outcomes?
The 2, 1,
You can get a one, two, three,
2, 3.
4, 5, 6,
Yes.
right?
Yes.
So what's NS? How many outcomes are there?
6.
6. Okay, you tell me. What's the probability of getting an even number? When you roll a dice, what's the probability of getting an even number?
Even number 2 over. Okay. Hold on. 1, 2, 3 over 6.
3 over 6. Perfect. What's the probability of getting a number greater than equal to 2?
Okay. Um, greater than,
Or at least 2?
1 over 6.
No, not 1 over 6. Greater than equal to 2. So
Okay.
that means greater than means more than, okay? So like from here to here.
Oh,
So
okay.
how many outcomes are there that are 2 or more?
Okay. We have 6 numbers. No, or 5, 5,
5. 5.
5 over 6.
5 over 6. What's the probability of getting a number that's divisible by 2?
Okay. That is two, two over six.
Are you sure it's 2?
A
Or is there,
number that is divisible. Okay. Four is two can go into four. Two can go into six.
is it 2 over 6 or 3 over 6?
It's two over six.
3 over 6, because 2 can go into itself,
Oh, okay.
right? So divisible by 2 is 2, 4, 6. So
Yeah.
there you go. Yeah, this is a pretty simple one because we're just rolling one dice, but this is the kind of like the deck card question, right? That one you're not familiar with, so it's tricky, and there's also 52 cards, but this is the same concept. It's the same formula as well. Now let's talk about probability a little bit more. There's two main ideas when it comes to probability. Any probability, okay, any probability of some event, I'm gonna call it E because the book uses E. Probability always has to be between 0 and 1, which means it cannot be negative. You cannot have negative probability. You also cannot have probability more than 1. I know in real life we say, I'm 200% sure this and that. No, that's bogus. That's not technically correct. Probability cannot be more than 100%. So that's the first idea, fundamental idea of statistics. Second idea is that when you sum up, this means summation. This symbol means summation. It just means essentially, it just means a plus. When you sum up all the events for an outcome, it must add up to exactly 1. See if there's a question, otherwise I'm going to come up with one. So here's a question. See, this one also requires you to know what a dice is and like stuff like that. So let's see if we can do this. When a single die is rolled, die just means dice. Find the probability of getting a 9. This is a trick question. What's the probability of getting a 9 when you roll one dice? It,
One.
is it possible to get a 9 when you roll a
No,
dice?
it's zero.
See, that's the kind of like fundamental knowledge they would expect you to know. So
Oh,
9 is impossible when you roll a dice. So 0 over 6, 0. 6 because there's 6 outcomes still, but 9, you cannot have a 9 when you roll a dice. So 0. When a
okay.
single die is rolled, what's the probability of getting a number less than
Yes,
7?
that's seven. Okay.
So that's your sample space. NS is still 6.
Mm.
So what's the probability of getting a number less than 7? Now, this is strictly less than 7. It's going to be 6 over 6, right?
Yeah.
Because there are 6 numbers here that are less than 7, and
Mm.
your NS is 6, so it's going to be a 1. Your probability is exactly 1, which is 100%, which is confirmed, basically. 1, probability of 1 means 100%. It's going to happen for sure. Now let's look at complementary events. I'm going to explain to you a bunch of ideas here, which is all part of this chapter. I'm just going to do it in a different manner because I like showing it visually. Something like this is what I'm going to do.
Okay.
So we're going to use Venn diagrams, very popular in statistics and also in set theory. So let's say there is a class. We're going to call that A. In that class, there are 9 people. And in the school, let's say there's 100 people. What's the probability of A?
Probability of A. One.
No, you got to use the formula, right? It's going to be, again, remember, the formula is this. The probability of any event E is NE divided by NS.
Okay.
where NS is the total and NE is like how many E's are there.
100.
So
100.
so using this formula, what's the probability of A? 9, right? There's 9 people in A, class A.
Is that 9 or Y? Is
Oh,
this
that's
one?
whatever. Yeah, it was a 9. Sorry, it was a 9.
Yeah, I got confused.
9 over what?
9 over 100.
9 over 100. Complement event is denoted by a bar. So we can call it PA bar. That is the probability right here. It's inside of the rectangle, but outside of the circle. It's
Okay.
this bit. So in class A, there are 9 people. How many people are not in class A out of 100?
That is 91.
91. So the probability of A bar, which is the complement event of A, is going to be 91 over 100. But the most important part here is this. Complement events always add up to 1. Add up to 1. So here, if you were to add 9 over 100 plus 91 over 100, A and A bar, their probabilities would add up to exactly 1. Cannot be 0.99 or 101. Has to be exactly 1. So you don't need all of this to answer a complement event question. Let's say they just gave it to you. The probability of B is 0.3, and they ask you, what's the probability of B bar, the complement event? Let's say this is a question. Know that when you add complement events, when you add up the probabilities, they will always add up to 1, right?
Yeah.
So if one of them is missing, you just subtract 1 minus the other to get it. So here, if PB bar is missing, I can just do 1 minus the probability of B. 1 minus 0.3, 0.7. Therefore, the probability of B bar is 0.7. You just subtract it from 1. You subtract B from 1. Okay?
This particular one, I didn't get it like others. Can you please take it again?
Let's see if let me use an example the book has, if it has any examples. Oh, it does not have any examples. So complement events. I'm going to call it complements, but it's the same idea, complement events. It's denoted by a bar, okay? A bar. Let's say someone's going to a school. The probability that someone wakes up and goes to a school, I'm going to call this PS, is 0.99. Let's say there's a student, and the probability that that student goes to school is 0.99. What is the probability, okay? What is the probability that the student does not go to school? That is the complement event.
Okay.
So what is P? That the student does not go to school, does not go to school. And how do you find that probability? Well, you just do 1 minus the original event like this. So PS bar will be 1 minus PS. You just subtract the original probability from 1 to get the complement probability, okay? So here it'll be 1 minus 0.99, it'll be 0.01. So therefore, the probability the student doesn't go to school is 0.01. That's a complement event. You just subtract it from 1 to get the probability. Let's do some of these practice problems just to hone in the idea of complement. It's just the opposite. It's the not. It's the opposite. So selecting a month that has 31 days, what would be the complement event of this?
So it's going to be 30.99. You know?
So this is not asking you for probability. Let's make that distinction, okay?
Mm.
This is just asking you the theoretical idea. So in that example, the complement event was that the child does not go to school. So here, if our event is we select a month that has 31 days, the complement would be that we select a month that doesn't have 31 days, right? Select a month that has less than 31 days. Also works because you cannot have more than 31 days. Selecting a day of the week that begins with the letter T. So what's the complement?
Day of the week that begins.
So that does not, yeah, selecting a day of the week that does not begin with the letter T. So what are the days that begin with the letter T? You have Tuesday, yeah, and you have Thursday. So this is our original case. The complement event would be you can select Sunday, Monday, Wednesday, Friday, Saturday. So these five would be the complement event of this, okay? Rolling two dice and getting a sum that is an odd number. What is the opposite of odd?
Um,
Even, okay? Even.
Yeah, even.
So the complement would be, well, you're getting an even event. The opposite. You're getting
Yeah.
an even number. Part D, selecting a letter
So,
of, yeah,
okay, so there's no need because I was thinking that it's going to be three. So it's just going to be if it's not odd, it's going to be even, straight up.
yes, straight up. We're talking about dices, so yeah, you can only get odd and even numbers. But yeah, if we're talking about something else, because zero is the weird one, because zero is neither even nor odd, it's also neither positive nor negative. So if zero is part of your sample space, then things get a little bit tricky. But it doesn't happen a lot in statistics, because the minimum value usually is a one when you're talking about events. Okay, what about the last one? I
Letting a
don't know.
letter of the alphabet that is used
That
as
is
a
used as a
symbol
vowel.
for consonant. Yeah, I think it's also selecting a letter that is not used as alphabet. I don't know.
Yeah, I'll just be like selecting other letters, right? I don't know what the other letter is, but the other letters. Let's see the I don't know the answer to D. See, this is one of the prerequisite knowledge. This won't come in the exam. I wouldn't worry too much about these specific questions like these. What's the opposite of vowel or consonant? It's the letter Y, actually, apparently.
You're selecting the complement.
So the complement would be anything other than Y.
And why? Okay.
Okay, so here's some other prerequisite knowledge. But that one is not that. This one, I don't know where it comes from.
Ah, okay.
So let's do this next question, which is again is the idea of a complement event. In a study, it was found that 23% of the people surveyed liked vanilla. So there was a study. The total is going to be 100, right? Because they've given us a percent.
Yeah.
The total percent is going to be 100. And vanilla lovers is 0.23 or 23%. The question is, what's the probability that someone doesn't like vanilla? Okay, again, you can use this diagram right here to help you. See, this inside part of the circle is 23%. The total is 100. You see this red part on the outside? This is V bar. This is the people or the percentage that doesn't like vanilla.
Vanilla. Okay.
How do you think we get that? Know that it adds up to 100.
Yeah.
So the probability of V plus the probability of V bar, okay, always adds up to 100 or 1. If you want to think about it in terms of probabilities and not percentages, adds up to a 1. The probability of vanilla is 0.23. The probability of this, we don't know. That's our unknown. Equal to 1, right?
Mhm.
And you'll see that we can get the V bar, the complement event, by simply doing 1 minus 0.23, which will be 0.77. So the probability is 0.77. Probability is always expressed in decimals, not in percentage.
Oh, okay.
So if they said find the percentage, we will say it's 77%, but the final answer
Yes.
here, the probability is going to be 0.77.
Okay.
So again, see this comes over and over again. Complement events, they always add up to 1. So either one of them is missing, you can just subtract it from 1 to get the other. So they've given us a table here. We're going to use this table to answer some questions.
Yeah.
And this is basically the thing that we've been doing. NE over NS is the answer. Here, NS is always going to be the total 50. Let me just pull in the question. So they've given us a table of data, and we're looking for some of these probabilities. I need your help with this one. The total is 50. I'll give you that. This is your denominator, okay? That's going to be your NS. 50 is going to go in your denominator. Part A, a person has type O blood. So remember the formula? PE is
I
NE over
think it's
NS.
going to be 21 over 50.
It is what, sorry?
For type O blood is 21 over 50.
Done. Easy peasy. A person has type A or type B blood.
Okay. Type A is going to be type, okay, hold on. Then 2 add type A. No. 5 add type B. So it's going to be, should I say 22 plus, are we going to add type A plus type B over the total number?
Yeah, perfect. That's right. Yeah, so it'll be 22 plus 5 over 50,
5
27
over.
over 50.
Okay.
Part C, a person has neither type A nor type O. Now, this is where the idea of complement comes in. So we can't have type A, we can't have this, and we also can't have O. So we can't have this. So what are the remaining possibilities?
Type B and type AB.
Exactly. So it's gonna be so type A or O. Look at the way I write this. A or O, right?
Is
But
it
then it
A?
says,
Okay. I thought it's
but
going to
it's
be B or AB.
complement of A or O,
Okay.
which means probability of B
Mm,
or AB. Okay.
okay.
It's everything. This just means everything except A or O. So it's going
Mm,
to be B or AB, add them up. It's going to be 7 over 50.
mm.
Okay. Part D, a person does not have type AB blood. Again, does not means complement, right? So no AB. AB is not allowed. So this is not allowed.
Okay. It's not allowed. Okay.
So it's everything else except AB. That's one way to do it. So we are looking for the complement of AB. So AB bar, right?
Mm-hmm.
There's two ways to do this. I'll show you both ways. Either you use the formula where you know complement events always add up to 1. So PAB will be 1 minus P of AB. That's one way to do it. You just subtract the probability of AB from 1. So the probability of AB is going to be 2 over 50. So it'll be 1 minus 2 over 50. You plug that in a calculator, you'll get 48 over 50. So that's one way to do it. The second way is just by looking at the table. Well, we want no AB, so I don't want this. So that means I want A, I want B, and I want O, right?
Yes.
Um, 22 plus 5 plus 21, it should have been 22 plus 5 plus 21 over a 50.
About 50.
So that does also add up to 48 over 50. So those are the two ways of doing a complement event question. You either add up everything else or you find what you're looking for and then subtract it from 1. That one is not terribly difficult. Let's try another one. Very similar question. All right, a patient. So they've given us a table number of days stayed at a hospital and the frequency. A patient stayed exactly 5 days. What over what? We're looking
20.
for P5.
Okay.
Again,
5 over 56.
no, that's not right. It's not 5 over 50. You said 5 over 56?
Over
That's not.
1.
What's your NS here? Let's go one by one. So
Okay. Redness is 127.
5 over 127?
Yes.
No. Okay, I'll tell you why you're wrong. So this is the formula, right? We're looking
Yes.
for P of 5. Here, your event itself is staying in a hospital for 5 days. That's your event. That's neither NE, that's neither NS. NS is always the total. What's our NS here? 127, right? NS is always easy. It's just the total. NE is a little bit tricky. So here your NE would be, well, how many people stayed in the hospital for 5 days? 56. So P5, the number of people that stayed in the hospital for 5 days, the probability is 56. These are the people that stayed in the hospital for 5 days divided by the total. And that's the final answer for A. You're going to use the same formula, but they will make it a little bit tricky for you. Part B, a patient stayed fewer than six. Fewer than six. So does that mean 3, 4, 5, or does that mean 6, 7, or what does that mean? Fewer than 6 days.
7, 7.
No, no, no.
That
Fewer.
fewer than that is less than six.
So
Abi?
fewer means strictly less than. That 6 is not included, okay? So
Okay,
fewer in
3,
this
4,
case,
5.
3, 4, 5. Yes. So the probability of less than 6 is going to be probability of 3 or 4 or 5, right? Like that. And we know or just means a plus. So it's going to be 15 plus 32 plus 56 over 127. And then we add that in a calculator, whatever that is. So it's going to be 103 over 127. Final answer. Part C, a patient stayed at most 4. Remember, at most means it's the same thing as fewer, but with an inclusive. So the number itself is also included. Less than 6, 6 is not included. At most 4, 4 and lower are included. So what'll that be here? 4 or lower, right? So it's going to be either 3 or 4. See if that made sense. At most 4 means either you could stay 4 days or less than 4 days. In this case, I'm looking at the table, you can only do 3 or 4. If there was 1, 2 here, yeah, sure, we'll lump them in as well. But there's no 1, 2, so the minimum value is 3. That's why it's P3 or 4. So here it'll be 15 plus 32 over 127, 47 over 127. Final answer. The last one, D. A patient stayed at least 5 days.
Please.
You know what at least means? It's greater than equal to.
That is,
So we're
okay.
looking for greater
6,
than equal.
7.
Yeah, 6, 7. What about 5
6, 7.
itself?
Okay. Yeah, okay. That's true.
Yes, yes. At least means 5 itself is included. If it said greater than 5, then 5 would not be included. So here it'll be 5 or 6 or 7.
7.
So 5 is 56, 6 is 19, 7 is 5 over 127. That's
127.
24. That's 80. Did this make sense?
Very well.
This isn't too hard.
When he was teaching it, I thought it was very hard.
You thought this question was very hard?
Yeah, but it doesn't look that hard.
No, I'm just using this formula right here. Look at the formula. There's only two things in the formula. The denominator for all the questions is always the same. So for A, B, C, D, every single time you're doing over to 127, right? Now, the only thing you need for all four of these questions is the numerator. And the first one says exactly, so you don't even have to worry about adding anything else. So for the first one, that's why it was 56 over 127. But for B, C, and D, you just need to know what at most, fewer, at least, and greater mean. And if you know that, you know, do I want to go down? Do I want to go up? Do I want to include that number, right? This isn't that hard. Hard part will come. I'm not saying this course is easy. Hard part will for sure come when we get to like normal distribution and whatever. But this part, at least for now, chapter one, two, three, they're not too bad.
Okay.
Cool. I think that's it for the class. So we're just in 1 hour, right?
So now, will you teach me tomorrow?
Can I teach you tomorrow? Yeah.
Okay. I
What
will
time
wait.
works for you?
Tomorrow is okay.
Monday? It's a holiday. I don't know if it's a holiday
Oh,
where you are.
okay. Yeah. Okay, can we do Tuesday?
Yeah.
Okay. So let's do Tuesday and let's do 2 hours, please.
Cool.
Okay.
So did you find this class helpful?
Very, very helpful.
What I'm gonna start doing, okay? I don't know if you noticed, but I recorded